viewers, this is Raji. When you learn the common names of some organic compounds, you might have come across certain prefixes like tertiary butyl, isopropyl, secondary butyl, normal pentyl, like that. At least for some children, it is too difficult to identify this particular group and even to draw the structure also. So in this video, we are going to learn an easy method so that you will be memorizing these groups forever, and at the end of the video, we will be doing some important examples also so that you will become perfect with it. So let's see how to do this one. See this one. Before we learn the common names of prefixes, we should have a clear idea about primary, secondary, tertiary and quaternary carbon atom in an organic compound. What do you mean by this primary carbon atom? In some books, as a short form, we will write it as 1 degree also for primary carbon atom. A carbon atom which in turn is directly attached to only one other carbon atom. If so, this carbon atom we call it as primary carbon. Why? Because it is directly bonded to only one carbon atom, right? Yeah. And what about this carbon atom? It is directly bonded to only one other carbon atom. So this is also primary, correct? What about this one? This carbon atom is directly attached to three other carbon atom, 1, 2 and 3. If so, we call it as a 3 degree carbon atom or tertiary carbon atom. Understood? What about this one? This carbon atom is directly bonded to two other carbon only. If so, we call it as a secondary carbon. We will write it as 2 degree as a short form. So this is secondary carbon atom. Okay. And what about this carbon atom? Yeah, which in turn is directly attached to 4 other carbon atom. This kind of a carbon we call it as 4 degree or quaternary carbon atom. Understood? Now only 3 are remaining. Try that. Yeah. What about this one? Which in turn is directly attached to only one carbon atom. So this is primary carbon. What about this carbon? Directly bonded to only one other carbon. So this is also primary. And what about this one? This is also a primary carbon atom. Right? Now you have a clear idea about how to identify primary, secondary, tertiary and quaternary carbon atom in an organic compound. Okay, so let's move forward. Now see this one. How to identify normal butyl, isobutyl, secondary and tertiary butyl groups. For this, there is an easy method. The only thing we need to memorize is that butane has got two isomers. One is normal butane. We will write it as n-butane also. And the one that is having one branching. Correct? No? We call it as isobutane. Okay. Now what we are going to do? We are going to remove one hydrogen atom from the last carbon atom. Right? And we are going to attach a substituent. Whenever the substituent is attached to the N carbon atom, we don't want to change the name of this isomer. So how to tell the common name of this compound? N-butyl chloride we will say. Agreed? Now we have attached the substituent to the N carbon atom. Now what's the other possibility? It can be attached to this carbon atom also. So write and see what will happen. CH3, CH2, CH, Cl and here it is CH3. Now what's the common name of this compound? First of all, we will have to check which isomer is this one. 4 carbon atom having a straight chain. So this is normal butane only. Okay, yeah. Then you will have to check whether the substituent is attached to the N carbon atom. If it is attached to the N carbon atom, we don't want to change the name of the isomer. We will call it as normal butyl chloride. But see here the substituent is not attached to the N carbon atom but it's coming in the middle. If it is coming in the middle, you will have to check which carbon atom is this one. That means, is it primary, secondary, tertiary or quaternary? Here, the substituent attached carbon atom, that is this carbon atom, is directly bonded to two other carbon atom. So this will be secondary. So what will be the name of the compound? We will say that secondary. Total how many carbon atoms are there? 4 are there. So secondary butyl. Then at the end we will add chloride. Secondary butyl chloride. This will be the name of the compound. Easy. Now, question may come to mind, okay, what about if chlorine is attached to this carbon atom? Yeah, that time also the compound is same, no? Right, and see, this is a secondary carbon, right, no? So, this compound also will be having the same name, secondary butyl chloride. Okay, why? Yeah, because both these carbon atoms are equivalent. Got it? Yes. So, what about this one? This is isobutane. Now, replacing this hydrogen atom, we will attach a substituent. Write and see. CH3, CH, CH3. All these groups are as such. From the N carbon atom, we are replacing a hydrogen by chlorine. First, we will have to think about which is this isomer. 4 carbon atoms with 1 branching. So, this is isobutane. Whenever the substituent is attached at the end, we will use the same name, isobutyl chloride. Okay, this will be the name of the compound. Okay, yes. Now, what's the other possibility? Chlorine can be attached to any other carbon atom other than the N carbon atom. So, what might be the possibility? We can replace this hydrogen. Okay, write and see. CH3, C, CH3. Yeah, here also CH3 and we are attaching a chloro group over here. See this one. Then which is this isomer? 4 carbon atoms are there with 1 branching. So this is isobutane only. But see this one, chlorine is not attached at the N carbon atom. It is coming in the middle, right? So that time we will be using primary, secondary, tertiary and quaternary. Okay. So this carbon atom to which chlorine is attached is directly attached to how many other carbon atom? 1, 2 and 3. Okay. So what will be the name of this isomer? Tertiary. Then 4 carbon atoms are there, no, totally. So we will write it as butyl. Okay. Again we will write it chloride. Tertiary butyl chloride. This will be the name of the compound. Got it? Yes. Now see this one. In the same way, we will have to identify normal pentyl, isopentyl, tertiary and neopentyl groups. So which is an easy method to do that? We will have to recollect the isomers of pentane. Pentane has got how many isomers? 3 are there. Okay, one will be having a straight chain and we call it as n-pentane or normal pentane. And the other one with 1 branching and we call it as isopentane. Okay. Then one more possibility is there in the case of pentane. 2 branching will be coming. Okay. If 2 branching is present, we call it as neopentane. Agreed. So if you could recollect the isomers of pentane, easily you can identify and memorize these groups also. How? We will write and see. First, let's consider normal pentane. We are going to replace 1 hydrogen from the N carbon atom and attach a substituent. Write and see. Okay, this will be the compound. What will be the common name of this compound? So that time we will have to think about the isomer. 5 carbon atoms are present and it has got a straight chain also. So what will be the name of this compound? Of course, we can write it as n-pentyl chloride. Okay, we were telling that if the substituent is coming at the end of it, okay, the same name of the isomer we can use. Now, what's the other possibility? Chlorine can be attached to this carbon also, and this carbon also. These are the other possibilities. Anyway, these 2 compounds are equivalent only. Correct, no? This compound, the middle one is different. So we were telling that whenever the substituent is attached to the N carbon atom, we will be using the name of that isomer directly. We don't want to change it. N-pentyl chloride. But here the chlorine is coming and attaching to the middle carbon. So we will have to think about what type of carbon is this one, which in turn is directly attached to 2 other carbon atom. Okay. So this is secondary. So we can write it as secondary pentyl chloride. Okay, But what about the second one? Here chlorine is attached to this carbon atom, the middle carbon atom. What about this one? Yeah, which in turn is directly attached to two other carbon atom. So this is also a 2-degree carbon. So we will have to call this also as secondary pentyl chloride. Okay. Because of this confusion, this common name secondary pentyl chloride, we won't be using it at all. Got it? No? So you should remember it. Okay. In order to name these compounds, yeah, we will have to go for IUPAC name only. Usually, yeah, we won't be calling it by their common names. Understood? So you should remember about it. Now, what about the next isomer? Isopentane. 5 carbon atoms will be there and 1 branching also will be there. What we are going to do? Replacing 1 hydrogen atom from the last carbon atom, we are going to attach a substituent. Write and see how does it look like. Yeah. What will be the common name of this compound? That's a question. So that time itself we will have to think about which isomer is this one. 5 carbon atoms are there, 1 branching is also there. So this is isopentane. Then what we will have to see, where the substituent is attached we will see. Okay, it is not in the middle, it is at the N carbon atom. Okay, so we don't want to change the name of the isomer. What will be the name of this compound? Yeah, we will write the common name as isopentyl chloride. So easy, right? No? Okay. Now, think about one more possibility. Yeah, see, replacing this hydrogen. Okay, we are attaching a substituent. Then what will happen? Write and see. Yeah, this is the compound. What will be the common name? Yeah, that time itself we will be looking at this isomer. See, this will be having 5 carbon atoms with 1 branching. So this will be definitely isopentane only. Then we will have to see where the substituent is attached. Okay, it is not attached to any N carbon atom. It is in the middle. So that time, yeah, we will have to identify what type of carbon is this one. Yeah, this carbon atom is directly attached to 3 other carbon atom. So this one will be tertiary. Okay, so what will be the common name of this compound? Tertiary pentyl chloride. It's so easy, right? Yeah. Now itself, question will be coming to mind. And what about if chlorine is attached to this carbon and this carbon atom? Yeah, that time we won't be using any common name. That time you will have to go for IUPAC name only. Understood? Yeah. Now, one more isomer is there, that is neopentane. Okay, what is that? 5 carbon atoms will be there and a 2-2 branching also will be present. So, in this case, what we need to do? Yeah. Replacing the hydrogen atom that is attached to the last carbon atom. Okay, we are attaching a substituent. Write and see how does it look like. This will be the compound. Okay, now what is the common name of this compound? Yeah, that time itself we will have to see which isomer is this one. 5 carbon atoms are there, 2-2 branching are also present. Chlorine is attached to the N carbon atom. In this case, we don't want to change the name of the isomer. So what will be the name of this compound? Neopentyl chloride. Okay, so if you are learning using this method, yeah, you will never become wrong. Okay, got it. Now see this one. In the same way, in some questions you will be getting sometimes normal propyl group also, isopropyl group also. So how to identify these groups? For that you will have to write propane. Propane is a 3 carbon compound. We know that. Okay, and there are 2 possibilities for the substituent to be attached to the N carbon atom also and this middle carbon also. Write and see. See, these are the only 2 possibilities. When the substituent is attached to the N carbon atom, what will be the common name of this compound? We will write it as N-propyl chloride. Normal propyl chloride also we will say. Okay. Here the substituent is not attached at the end, but yeah, it is attached to the middle carbon atom. So you can assume the same compound as isobutane. Yeah, see, straight chain will be there and from there one branching is also coming. So in the same way, if you are assuming, you can immediately recollect the name of this compound. What will be the common name? Yeah, that is isopropyl chloride. Only this one you should remember. Now let's see some questions related to that. We will check whether we will be able to do that. Okay. Now see this one. We are going to write the common names of these compounds. See, this is an alcohol, okay, which in turn is attached to this group. So first of all, we will have to identify which isomer is this one. Total 4 carbon atoms are there with one branching. Okay, if so, this will be isobutane only. Okay, then you will have to see where the substituent is attached. It is not at the N carbon atom, it is in the middle. So that time we will have to identify which carbon is this one. In this case, this is a tertiary carbon atom, right? So what's the common name of this compound? Tertiary butyl alcohol, we will say. Easy. Yeah. What about this one? 1, 2, 3, 4, 5. Total 5 carbon atoms are there. Of course, it is a pentane. Which isomer is this one? Yeah, straight chain with one branching. This is isopentane. Now, we will have to observe where the substituent is attached. It is at the end only, right? So, what will be the common name of this compound? Yeah. Isopentyl alcohol. That will be the common name of this compound. Got it? What about this compound? How many carbon atoms are there? 1, 2, 3, 4 and 5. Okay. Total 5 carbon atoms are there, and that is also with 2 branching, right? And the OH group is attached at the N position. So what we need to think about? Yeah, which is this isomer we will have to think about, right now? Okay, which isomer is that one? Yeah, 5 carbon atoms with 2 branching, that is neopentane. Okay, and OH group is attached at the end. So what will be the name of this compound? Neopentyl alcohol. Agree? Okay, it's so easy. What about the last one? 3 carbon atoms are there. Either substituent can be attached to the N carbon atom or to this second carbon atom. Okay, if it is attached at the end, we will be using normal. Now, here it is attached to the middle carbon atom. So, we will have to use isopropyl alcohol. That will be the common name of this compound. It's so easy, right? Yes. Now see this question. This question was asked in a 2013 NEET paper. The structure of isobutyl group in an organic compound is. Isobutyl group means what should come to your mind first? Yeah, it will be having 4 carbon atom, and isobutane is the isomer with one branching. If you are using the same name of the isomer, see where the substituent will be coming and attaching at the end. Out of this one, which one will be the correct option? The first one. It's so easy. Okay. Hope you might have understood the concept so well. Thanks for watching. See you in the next video. Till then, bye for this time.